Hello everyone. Welcome to our construction technology course. Today, we will learn the basic knowledge and initial processing of reinforcing steel. We will focus on the classification of reinforcing steel used in construction and its initial processing after delivery, including cold stretching, cold drawing, rust removal, straightening, and bending, and forming. In reinforced concrete structures, commonly used steel materials include reinforcing bars and steel wire. Rebar is categorized into hot-rolled rebar and thermo-mechanically treated (TMT) rebar. Hot-rolled rebar is further divided into hot-rolled deformed rebar and hot-rolled plain round rebar. The grades of hot-rolled deformed are designated by the prefix HRB followed by their minimum yield strength value. HRB 335, HRB 400, HRB 500. The grade of hot-rolled plain round rebar is HPB 300. The grade of TMT rebar is RRB 400. Rebar is also classified by diameter into steel wire, small diameter rebar, medium diameter rebar, and large diameter rebar. Steel wire includes cold-drawn wire, carbon steel wire, and indented wire. Rebar with a diameter greater than 12 mm, classified as medium diameter or large diameter rebar, is typically cut into lengths of 6 to 12 meters and delivered in bundles. Steel wire and small diameter bars, 6 to 2 mm in diameter, are usually delivered in coils. To fully utilize the properties of steel, increase the strength of rebar, save steel, and meet the requirements of pre-stressed rebar. Various initial processing methods are used for rebar, including cold stretching, cold drawing, descaling, straightening, cutting, and bending, and forming. First, let's learn about cold stretching. Cold stretching is applying a tensile force to rebar at room temperature, beyond its yield point. This induces plastic deformation in the rebar, which is irreversible. During this process, the crystals inside the rebar slip along the weakest crystallographic planes. The crystal lattices on the slip planes deform and fracture, producing an uneven surface texture on the slip planes. This hinders further slippage, resulting in internal structural changes. These changes increase the yield strength of the rebar, a phenomenon known as strain hardening. Second, cold drawing. It involves drawing HPB 300 grade rebar, typically 6 mm in diameter, at room temperature, through specially designed alloy dies, by repeatedly applying high tensile force, reducing its diameter to produce steel wire. This process induces plastic deformation, improving the rebar's mechanical properties. Third, descaling. In construction, the rebar surface must be kept clean to ensure bond strength between the rebar and concrete. All grease, contaminants, and rust on the rebar must be removed before use. Rebar with scaly or flaky rust must not be used. Descaling methods are divided into manual and mechanical methods. Manual tools include wire brushes, angle grinders, and emery cloth. Typically, rust is first removed using a wire brush, then polished with emery cloth. This method is simple and low-cost, but labor-intensive and inefficient. Mechanical methods include pneumatic or electric tools, rebar cleaning machines, and sandblasting. These methods are highly efficient and time-saving. Next, let's take a look at a sandblasting operation on site. Fourth, straightening. Coiled rebar upon delivery and any bent rebars need to be straightened before use. Straightening can be classified into manual and mechanical. Manual straightening often uses winches and iron posts. Mechanical straightening often uses rebar straightening machines and electric winches. Let's watch a video of a rebar straightening machine in operation. Fifth, bending and forming. Rebar can be bent using either manual methods or mechanical equipment. All bending must be done at room temperature and must not involve heating the rebar. Manual bending requires simple tools and offers accurate results, while mechanical bending reduces labor intensity and improves efficiency. Safety precautions must be observed during operation. Manual bending is suitable for rebar with diameters of 12 mm or less, typically using manual levers. For thicker rebar, steel plates or jawed wrenches are often used. Before bending thicker or complex-shaped rebar, mark all bending points clearly, according to the cutting list dimensions. When using a bending machine, the central pin diameter should be at least 2.5 times the rebar diameter. An eccentric bushing should be added to the forming shaft to accommodate rebars of different diameters. Last, let's watch a video of a rebar bending machine in operation. In today's lesson, we covered the basic knowledge of rebar. Steel used in construction is classified into rebar and steel wire, according to its chemical composition. Rebar can be divided into hot-rolled and TMT rebar. Hot-rolled rebar, the most commonly used, is classified into hot-rolled deformed rebar and hot-rolled plain round rebar. Be sure to remember their respective grades. We also studied preliminary processing techniques including cold stretching, cold drawing, descaling, straightening, and bending and forming. Make sure you fully understand the construction procedures for each of these methods.